Homework solution 4.1. Develop a table showing the mechanical rate of rotation for an AC generator of 2, 6, 10, and 14 poles operating at frequencies of either 50 or 60 hertz. The givens for this problem are, sorry, I have a green pen selected there. The givens for this problem are the number of poles. We've got a couple different scenarios. Symbol for poles is capital P. So we've got 2, 6, 10, and 14. And then we've got frequencies, two of them. A lot of times when we start talking about synchronous machines, we give the subscript E to symbolize that that's an electrical frequency. So that's 50 hertz or 60 hertz, two scenarios. And what we're asked is the mechanical rate of rotation. So we're finding the RPM of the machine, which is given the symbol N sub M for mechanical rate of rotation. The solution to this is that we just need to know what the relationship between rotational frequency, electrical frequency, and poles are, and that is the electrical frequency of the sinusoidal output of a synchronous generator is equal to the mechanical rate of rotation in RPMs times the number of poles over 120. So that's going to be rearranged to show that the mechanical rate of rotation, which is what we're asked to solve for, is just equal to 120 times the electrical frequency of the voltage source divided by the number of poles. So we just need to fill that in, fill our table in. We've got number of poles, 2, 6, 10, and 14. And then we've got the RPM at 60 hertz and the RPM at 50 hertz. So I'll just do an example of one of these calculations and then give the answers for all of them. So Nm is going to be 120 times 60 divided by the number of poles. So let's put a 2 in there. So that's going to give us 3,600 rotations per minute. So all we have to do is we have to plug in these different values of P here and the different values of frequency here, and we'll get 3,600 RPM. We see that as P increases, the RPM decreases. So that's 1,200, 720, 514.3. So as the number of poles on the generator increases, you don't have to spin as fast to produce that 60 hertz. And then at 50 hertz, well, the frequency is a little bit lower, so the associated RPM is going to be a little bit lower. So, for example, that would be Nm equals 120 times 50 over 2, which is 3,000 rotations per minute. So that's 3,000 RPMs, 1,000 RPMs, 600, and 428.6. Again, RPMs decrease as the poles increase, and if you compare a higher frequency system to a lower frequency system for the same number of poles, the higher frequency system needs to spin a little bit faster.